Good day, everyone. For today's session, we will be learning on how to find the nature of the root. Before that, let us describe some terminologies being used in finding the nature of the roots. The first one is the value of the expression b squared minus 4ac is called the discriminant of the quadratic equation ax squared plus bx plus c is equal to 0. The next one is this value can be used to describe the nature of the roots of a quadratic equation. It can be 0, positive, and a perfect square, positive, but not a perfect square, or negative. And the last one is the nature of the roots of quadratic equation. We may describe the nature of the roots of quadratic equation based on the value of the discriminant using the rules below. Alright, so the first rule of the nature of the roots of quadratic equation, when b squared minus 4ac is equal to 0, then the roots are rational numbers and are equal. The next one is when b squared minus 4ac is greater than 0 and a perfect square, then the roots are rational numbers but are not equal. The third one, when b squared minus 4ac is greater than 0 but not a perfect square, then the roots are irrational numbers and are not equal. And the last one, when b squared minus 4ac is less than 0, then the equation has no real roots. Alright, for you to understand the rules of the nature of the roots, let me give you our first example. Describe the roots of x squared minus 10x plus 25 is equal to 0. The first step is identify the values of a, b, and c. From this example, the value of a is equal to 1, b is equal to negative 10, and c is equal to 25. The next step is substitute these values of a, b, and c in the expression b squared minus 4ac, then simplify. Right? So, since negative 10 squared is equal to 100, then negative 4 times 1 times 25 is equal to 100, then 100 minus 100 is equal to 0. The third step is describe the nature of the roots. Since b squared minus 4ac is equal to 0, based from the rule, the nature of roots is rational numbers and are equal. To check if our answer is correct, let us proceed the next step. Check by determining the roots of quadratic equation using any of the methods of solving quadratic equation. In this case, I will be using factoring method. The factor of x squared minus 10x plus 25 are the quantity x minus 5 and the quantity x minus 5. Then split these factors that is equal to 0. So we have x minus 5 is equal to 0 or x minus 5 is equal to 0. Obviously, the value of x is equal to 5. They are identical or equal. Therefore, the roots of the quadratic equation x squared minus 10x plus 25 is equal to 0 are rational numbers and are equal. For our next example, Describe the roots of x squared plus 5x plus 6 is equal to 0. First step, identify the values of a, b, and c. From this example, the value of a is 1, b is 5, c is 6. The next step is substitute these values of a, b, and c in the expression b squared minus 4ac, then simplify. Alright, so as we can notice, the value of b squared minus 4ac is 1. So the third step is describe the nature of the roots. B squared minus 4ac is equal to 1. B squared minus 4ac is greater than 0 and a perfect square. Since 1 is an example of a perfect squared number, then the nature of roots are rational numbers and are not equal. For the fourth step, check by determining the roots of the quadratic equation using any of the methods of solving quadratic equation. Alright, so as we can see, I'm using factoring method. So, ang x natin, we have negative 2 and negative 3. So, therefore, the roots of quadratic equation x squared plus 5x plus 6 is equal to 0 are rational numbers and are not equal. For our third example, again, you're going to describe the roots of x squared plus 8x plus 3 is equal to 0. Just follow the steps. Alright, so the first step is identify the values of a, b, and c. From this example, the value of a is equal to 1, b is equal to 8, and c is equal to 3. The second step is substitute these values of a, b, and c in the expression b squared minus 4ac, then simplify. Alright, so as we can notice, the value of b squared minus 4ac is equal to 52. The third step, describe the nature of the roots. B squared minus 4ac is equal to 52. B squared minus 4ac is greater than 0 and not a perfect squared number. Since 52 is not a perfect squared number, then the nature of roots are irrational numbers and are not equal. For the fourth step, check by determining the roots of quadratic equation using any of the methods of solving quadratic equation. Alright, in this case, I will be using quadratic formula. Alright, so we have x squared plus 8x plus 3 is equal to 0. As I mentioned, I will be using quadratic formula. So if we are going to substitute the values of a, b, and c in this quadratic formula, we can have x is equal to negative 4 plus or minus the square root of 13. So therefore, the roots of quadratic equation x squared plus 8x plus 3 is equal to 0 are irrational numbers and are not equal. And for our last example, describe the roots of 2x squared plus 3x plus 5 is equal to 0. First, identify the values of a, b, and c. Since from this example, a is equal to 2, b is equal to 3, and c is equal to 5. Alright, so the second step, substitute these values of a, b, and c in the expression b squared minus 4ac, then simplify. So we have b squared minus 4ac is equal to negative 31. The third step is describe the value or the nature of roots. B squared minus 4ac is equal to negative 31 is less than 0. So therefore, the nature of roots is no real roots. To check if our answer is correct, okay, let us use any of the methods of solving quadratic equation. In this case, I will be using quadratic formula. Alright, so we have this one. Substitute the values of A, B, and C to the given quadratic formula. So the value of x is equal to negative 3 plus or minus the square root of negative 31 all over 4. So therefore, the roots of quadratic equation 2x squared plus 3x plus 5 is equal to 0 are not real numbers.